So whatever we discussed so far, let's say if I just draw things, so you see what we discussed so far in the time region. From the well test we got certain information right from the WELLBORE storage. Okay, WELLBORE storage, and let's say if I put an instrument here, okay, the electronic memory gauge, so we are recording with time. And what we got, if I just put a time domain, so we have three different time domain. One is early time region, then you have middle time region, and the end time region, or maybe the late time region. Okay, late time, middle time, late time region. So what information we gather in early time region? Can anybody just, Lakshmi, what are the information yeah, tell me.
Formation damage and WELLBORE skin, WELLBORE storage.
Yes.
WELLBORE storage effect.
Okay, so initially what we got, that means WELLBORE storage, then we are getting the normal reservoir KH, then we are getting the boundary effect, isn't it? Okay, so today we'll discuss regarding the little bit the early time region effect. So we have two important aspects. One is our WELLBORE storage effect, okay, WBS WELLBORE storage effect, and another is your skin. Okay, so particularly two things we'll discuss today. One is, so how things generally in your build-up study and drawdown study. So if I just put two graphs here, is it visible, the graphs?
Yes, sir.
Visible, no? So in case of
Yes,
drawdown study, if I do a pressure versus time, and build-up study, pressure versus, this is build-up and this is drawdown. Okay, drawdown. So if just put, so in case of drawdown, we got graph like this, isn't it? Pressure versus time, and in this case we got graph like this. Okay, so that means the early disturbance is considered to be the WELLBORE storage effect and due to the skin. Okay, so I am not going here your differences, only pressure. So what it is there, so what are the factors which involve actually our particularly. Okay, so now okay, so you see there is a skin factor in terms of the additional pressure drop due to damage, or maybe you may have the stimulated well where you will get certain effect. Okay, so this is how what we got in case of initially part. Okay, so now the skin effect reflects the difference in pressure drop that exists in the vicinity of the well between the reservoir as it is, and if something is there, either it can reduce the permeability or it can enhance the permeability. Okay, so so why, that means by different way we could understand it. So what, by using infinitesimal skin of a finite thickness and the effective radius method. So what is the meaning of infinitesimal small skin? Anybody? That means one is a skin of finite thickness, that means you have certain age value. Small skin means, very small skin means you have more or less no change in the permeability value, and another is effective radius method. What is I will come one by one the this part, and then we will discuss. Okay, so now this is what the graph is. Okay, so in case of no change in the pressure value, as it is continuing right from the external boundary to the wellbore. If there is no change, then what you have, you may consider very small skin. Okay, but if you have certain skin, so why the pressure is dropped, I'll just go to the next slide and come to you. So if you see this, okay, so the graph you could see at the end, is it visible now, the graph? Okay,
Yes, sir.
so you see the three situations are there. Okay, right from the external boundary, wellbore boundary, if I just come down, the slope of the graph is more or less, the pressure graph is more or less same up to the marked portion. Okay, so then we have three lines. One is your red line, one is the same black line continued, and another is the blue line. So that means if you see the pressure is not changing at all and it's continuing, what is the meaning of it? You don't have any skin, isn't it? And if you go to the red line, so what is the meaning of it? That means the pressure drop due to this near ball area is more than what is expected. So the meaning is you have more skin, that means more less permeability compared to the existing area of the reservoir. And if you go to the blue line where you can see S denoted here -2, that means we have permeability increase in this area. That's why whatever expected pressure we should get in the wellbore, we are getting more pressure. Okay, so that means the permeability has increased. That means this is a stimulated well. So that means by understanding mathematics as well as our normal physical part, we can get. So what is the infinitely small skin? If you go here, okay, just if you see, you can see here. Uh, Okay, so this is del PS. This del PS is due to the change in pressure due to the effect of skin. Okay, so you have different values for this. Okay, del PS. So in case of positive skin, you need to add this pressure. Okay, in case of negative skin, you need to subtract it. Okay, so in harsh and avant-garde approach, the pressure drop due to the skin effect is located in an infinitely thin film around the wellbore. So that means this value is related to certain parameters which is related to the reduction of your permeability value. If I just go, yes, so if you have a finite thickness, if you see, we have two radius. One is our wellbore radius, another is radius which is related to your skin. Okay, so continuous. So if you see outside the skin, we have a permeability K, and whereas inside the skin, the permeability of the reservoir or maybe surrounding area is Ks. Okay, so that's why if the difference of pressure drop between the real reservoir and the reservoir uniform right up to elbow is expressed including this, and this is what, if you have finite skin, you can express it in terms of the two diameter. One is your diameter of your well only, and another is diameter of your skin. Okay, so that actually gives you the formulation which is related to your logarithm scale. Okay, so that you can see here with the skin. So K minus Ks by 1 into ln Rs by Rw. So the skin factor may be calculated from the properties of the altered zone. If A means the apparent skin, if apparent skin is less than the K, okay, apparent skin means if you see here, okay, skin is positive. If it is 1, then it is 0, and if you, that means we are considering certain part in this skin area, and that actually there is 3 line. If you just put it in the form of your this K, Ks actually is related to the skin is 0. In case of the skin is 0, when you have K apparent, this is Ks you can say, okay, or maybe Ka apparent skin or permeability in the skin area. Okay, so now you can see here, now you can correlate when you have a 0, that means there is no difference of the pressure drop right from the external boundary to the wellbore, whereas if you have a positive skin, K more than K apparently more than K, that means reservoir K and the skin K is more, permeability is more, then we'll get a stimulated effect, whereas in case of your K apparent skin less than the reservoir permeability, then we got a skin is positive value. So if you go through the values here, S equal to -2 in case of your stimulated skin, and in case of here you can get S equal to +5. So numerically we can get the value particularly after the well test. Okay, so now this is what it is. What is the physical meaning? Can anybody explain me? Nikhil, you
Uh,
see two lines are there, isn't it? Okay, one is here, another is here. So what is the physical meaning? I just if I just stop my sharing and just show you in the diagram. Okay, so what is the meaning of physical meaning? So that means if you have a positive skin, what you see, this is one line which is positive, then we have normal, and this is negative. Okay, skin. So when you are getting this extended, that means you should get this pressure here, but you are getting more pressure here. What is the meaning of it? That means this pressure is higher pressure. Okay, so that means your Wellbore is maybe let's say here. Wellbore radius is here. Okay, because you are getting this pressure, you should expect in the normal case it should be, you see this is the same line. Are you getting it?
yes,
That means when you have a negative skin, it means you should, in case of normal, you should get a pressure down here. But as the you have a stimulated area, that means you are getting the pressure here as if your Wellbore radius has now extended up to this. Are you getting this point?
Yes, sir.
Agreed or not?
yes, sir.
Okay, and when you have this negative positive skin more, that means you are getting the pressure. That means you have an, the Wellbore radius apparently is infinitesimally small diameter. That is the meaning, physical meaning of positive skin and negative skin. Positive skin means I should expect, in the normal case, I should expect a pressure in the Wellbore, which I am getting more pressure. That means it appears my Wellbore has been expanded, because I am getting more pressure, so that means it should be here or maybe here. But in case of negative positive skin, I should expect pressure normally here, but I am getting less pressure than this. So my Wellbore has been reduced. At least it may be, it is showing me that my okay, so now this graph, now you can see the effective radius method consists in replacing the real well with a radius RW and skin S by a fictitious well with a radius RW dot and zero skin. Okay, so this is what the physical meaning is. So when you have actually here, you can see KS, that means this is actually when you have a KS skin more, less than this, that means you are getting an infinitesimally small. Okay, so P of effective radius, P real. This is the P real, and this is the, you see when you have KS, then the skin less than the normal, so you are getting the effective radius as decrease. Okay, why? Because you see your effective radius is here, and now you are getting here, so RW dot is here. That means you see it's a normal. Okay, so that is how the, okay, so this is the mathematics part. Okay, so expressing the pressure drop with Darcy equation, we are adding this linear scale. So what we RW dot, that is effective Wellbore radius, is related to the actual with the exponential relation with the skin. The effective radius method is used to represent the skin analytically in all possible cases, including when the skin is negative. When the skin is negative, that means we have the stimulated area. It appears to me the Wellbore radius has been decreased, infinitesimally small. And how about the values? If you just go through this line, you can easily say, okay, these values. So if the skin factor is negative, then the stimulation, the effective Wellbore radius will be greater than the actual Wellbore radius. So I have, okay, I have shown you here negative, so this has been expanded. Okay, just let me introduce my small, okay, Nikhil, and the speaker part. Okay, Okay, so it is this part is reducing your A. Okay, so I'll just put it here. You can see the skin, na?
No,
Hello.
sir.
Okay.
Yes, yes,
No,
yes.
no.
Apparent, when you have positive skin, you see skin, negative skin. Negative skin means you see your area has been enlarged. Your wellbore radius has been enlarged in case of your negative skin. But when you have a positive skin means it appears to you that your wellbore radius is infinitely small. So if the skin factor is negative, the effective wellbore radius will be greater than the actual. So why it is so? Because we should expect certain pressure in the wellbore, but the same, but we are getting more pressure. So that's why it appears, because if you follow this line, the more pressure you will be getting here, isn't it? So that's why it appears to me my wellbore radius has been expanded. The physical interpretation of this is that the well will behave as if it has drilled with larger wellbore radius. On the other hand, if the skin factor is positive, the well will behave as if it was drilled with smaller wellbore radius. Okay, so the mathematics, if you just go through it, it will be easily visible to you, the values. Okay, you see the values. Zero means whatever wellbore, so that when you are getting a zero skin, that means you are getting the exact wellbore radius. But if you have a negative, okay, so to determine if the values of skin is truly mechanical in nature, a number of situations that can cause an additional pressure loss as the fluid flow into the wellbore should be considered. Okay, and I'll just show you what are the difference. So you got it, this is normal skin. Okay, so any doubt so far? I am just putting everybody. So any doubt so far? Aditya, Sanjeev has joined or
No,
not yet
sir.
joined?
Yeah, yes, sir. I've joined it.
Okay,
So,
6 joined. So that means another 5 means Aditya, you Jain join.
Yes, sir. Yes, sir.
Oh, that's good. Very good.
good initiative.
Okay. Just let me try to put you. You put everybody your video on so that I just have a at least how many I can see. Sanjeev, Lakshmi. Okay, so Aditya. Then who are there? Okay, this is Nikhil. You joined. Jain. Okay, that's good. Okay, so so then all of you joined. Then but regular those who are coming to the class, they joined actually. Okay, so you as Nikhil, you give them the information also. Rahul and who is there? Rahul and Neil.
No, sir. Like, I haven't added them in the group.
Okay,
I don't
so
think that people would be joining because like, even the other lectures that are going on, they haven't
okay,
joined in.
okay. What about, so today is your first class running, or maybe you have earlier classes also?
We had some classes of this reservoir modeling and EOR.
Okay. Now today I have seen 4 classes lined up for you people. So
Yes.
okay, that's good. Then at least right from morning. So I'll continue with the same thing hopefully, and I'm preparing actually in a slightly different way. Okay, so I am now improving my, because I'm getting lot of time, not lot of time actually. I'm just trying to give you some idea. So Jane, where you were staying? Just
In my home, sir.
okay. So
Bangalore.
Bangalore. So everything is fine around there.
Yes, sir.
Okay, fine.
All good.
Okay. Now I'll continue. So any doubts so far in this?
No,
No,
sir.
sir.
Yes.
Okay, so that means we can understand the skin by just analyzing our different information and well test. Okay, so now you see, I don't know, you have gone through this sort of information earlier. So I told you earlier, this skin, it is not only for the skin or damage surround the wellbore, but it may be for different reasons also. And when we are conducting a well test, this information we need to put to understand actually for what reason the skin has been coming into picture. Okay, so if S greater than 0, the zone nearest the wellbore is very likely to be damaged. the permeability in the skin zone is much less than the permeability of the undamaged formation of a normal cage. Okay, the main factor responsible for this damage are, you can see, invasion by drilling fluid, that is generally we discuss. Partial well penetration, that means how much perforation you have done, all the perforation is not completed sometimes. Okay, that is one part. Partial well penetration, that means all the perforation is not completed or maybe not giving you the proper input of the flow. Then partial completion. What is partial completion? Anybody? If your pay thickness is more and you perforate part of it, that is called partial completion. Okay. And plugging of perforations, that means even if you perforate, but due to some regions your all the perforations are not helping you to enter fluid, so that is plugging. That may be due to sand incursion, maybe asphalt deposition, maybe wax deposition, precipitation. Okay, so organic and inorganic precipitation, another part. Okay, improper perforation density or limited perforation, that is sometimes what happened when we use dynamite or maybe dynamite gun to perforate. Sometimes all the guns may not blast, so that's why we may have different types of improper perforation. Okay, so that can cause this sort of skin, because ultimately what we expect a certain Q out of all the perforations, but it is not happening due to some reason, and that we need to understand. Is it the real skin which is damaging our permeability, or maybe due to some other reasons the flow within the well is not properly? Okay, so bacterial growth. Then we have dispersion of clays. Okay, so dispersion of clays, and then you have your presence of mud cake and of cements, and the presence of high gas saturation around the well bore. So water is there due to the high gas injection. So that is how we have the skin. So are you getting the point? Just the skin means, doesn't mean always it is the damage. It may be for different mechanical failure, or maybe the mechanical part involved, deposition involved. Okay, so any doubt so far? So skin, that is also we need to consider when we are stimulating a well with hydrofracturing. That time also we need to consider, and in case of anything, any problem, we just need to know. Okay, so now this is a figure. I didn't include all the mathematics here. Okay, so you can see here geometric sin, that is what? Partial penetration. You see in the first diagram we have a total pay thickness is high, but the perforation is not. You see we have 10 minutes now, it's automatically after 10 minutes it will automatically close, isn't it? Okay, okay. So this is one part. You can see this is geometric and converging flow, that is bottlenecking. We have the pay thickness higher, but we are only perforated few portions, or maybe the successful perforation is a few. Then second is geometric skin, partial penetration. We have the whole pay thickness H, but only we have perforated few part, and that's why you can see this type. After that you are getting a convergence of your flow. That's why it can also affect as a skin. Okay, so then you have your deviated wellbore. Deviated wellbore, you have perforation length, but you are not getting the proper entry of the fluid. So that is which is giving. So if you see the mathematics here, S equal to SD plus S theta. I have the mathematics here. Maybe I'll whenever we'll discuss that time, I may go through it and discuss it. Then we have the hydraulic fracturing. You see, this is this fracture, and what is the natural fracture? What is the difference between these two? Natural fracture already in the reservoir, and we have the hydraulic fracture. You see, hydraulic fracture, the length of the fracture is not extended up to the far. Okay, so that's why two effect is different. That's why initial part, when the things are entering into the wellbore, generally in the early time we got the effect of the hydraulic fracturing. But in case of normal reservoir, fractured reservoir, we may get the effect afterward also. We'll discuss that. Okay, so the behavior of the pressure graph in the initial stage and behavior of the pressure graph in the fractured reservoir. Then we have gravel pack. Gravel pack also having the effect as skin. You can see here, due to this is cement, we have a gravel pack. So that is also, this is skin due to gravel pack. We have a lot of parameters involved for calculating the skin. So when we are trying to understand the real skin or actual skin around the wellbore, we need to consider all the parameters to actually evaluate our situation around the wellbore. That is how we need to analyze when we are discussing. Okay. So you see here what we consider in general. So age generally less than 0, well is likely to be stimulated either by hydraulic fracturing or acidizing. Okay, so what is acidizing? Jane? Hello? What is acidizing? You have this production now?
Yes, sir.
Yes, sir.
Okay. What is isn't
the method of simulating well, sir.
yes, that means you are using acid to clean the surrounding of your wellbore. That is called two things. One is acidization, another is acid washing. So do you know the difference of these two?
Acid washing is just done to remove the impurities in the wellbore and the completion. Like
Yes, that means if you have done just within the wellbore or maybe perforation, that time we can consider it's an acid wash or acidizing or acidization. That means that can be stimulating actually. You are trying to go beyond your wellbore. Okay. So now if you see what we consider types of stimulation or completion, what we consider in general. Normal completion we consider 0 skin, small acid treatment -1, intermediate acid treatment -2, -3, then -4, -6, and massive fracture treatment in low permeable reservoir. So that is how we generally consider. And we could, by using our oil test, we could gather the information also. When you do certain workover jobs or acid treatment, is it really increased or is it has not yet increased? So that calculation also we could do. Okay, so this is one advantage of your well test if you do before and after. So what is wellbore storage? Okay, and how do you get this wellbore storage effect in our pressure or pressure derivative graph? Okay, so that is wellbore storage is called, okay, so after the production or after injection, wellbore loading or unloading as the effect of the wellbore. That means how much capacity of the material is there. Okay, is it, am I audible? Hello? Hello?
Yes, sir. You are audible,
Yes,
sir.
sir.
Okay, in case of drawdown, okay, so what is happening when we are cleaning the well or maybe during the drawdown or maybe loading the well after build up study. So how much, because you see two things are important. One, we are immediately closing on the surface and we are immediately maybe start producing from the surface, but the sand phase may not affected immediately, isn't it? So that means if the sand phase or perforation phase is not affected immediately, nothing will enter into our wellbore or maybe nothing is communicating. So that's why when we are getting initial phase of our pressure recording, that is related to the wellbore storage effect. That means how much we are unloading or loading, that is affecting the pressure, and that is how we need to understand. Okay, so practical viewpoint, the storage increase at the time to reach the infinite acting state line portions of the pressure drawdown curve or maybe the well testing. So that means that there is no immediate effect in the sand phase and reservoir is not start affecting immediately on the sand phase. Okay, so well test begins with a sudden variation in the well flow rate. This variation occurs in the well, okay, at the wellhead usually or closer to the formation in a DST or with a bottom hole certain. So what is there, you can immediately see. So what this part, the effect, that is what there is the production value. Okay, this Q T by QB, it's a reservoir volume. So you can see right from the near area, it is completely affected, but it is not, well head flow rate is not affected the sand phase away from it. So the surface flow rate when the well is opened is assumed to go at once from 0 to Q, but the bottom hole flow rate doesn't increase instantly from 0 to QB. The bottom of the well begins producing gradually. and that is why sand phase is not effectively affected immediately. Okay, so how much do we consider? The period when bottom hole flow varies is called the Wellbore storage effect period. That means you can see right from full value of your Q to the zero value. Okay, now so sorry, zero value to this value, this is not affected. So it is gradually. Okay, so that's why Wellbore storage is homogeneous with the product of a volume of compressibility. That means if we have different types of material inside the Wellbore, it may be a gas, it may be a light oil, it may be a heavy crude, it may be injection oil. So depending on that, we have to calculate our Wellbore storage effect, how long it will continue. Okay, so Wellbore storage is defined by C, volume change due to change in pressure. Okay, so now a dimensionless factor, generally we use CD by different parameters of the with total compressibility of the fluid also we include. Okay, so that is how we calculate. And naturally eruptive oil, the calculation scheme is different. Then we have naturally then we have the pumping oil, the calculation scheme is different. Okay, so depending on the value of the pumping rate, you should incorporate the parameters and calculate the Wellbore storage effect. So and then how long we should consider pressure variation. Okay, so if you see the line is changing, okay, so that means just after the well has been opened, the bottom hole pressure is mainly affected by the Wellbore storage effect. So you can get the value in dimensionless form, you can get the pressure, okay, and the PD. If well storage is constant, the bottom hole pressure varies linearly versus time as long as the Wellbore storage has a dominating effect. So you can see here. But when it is leaving the slope one line, straight line, when the bottom hole pressure drop is plotted versus time is used to complete C. That means when it is leaving this point of straight line, that means we are now in a zone where the Wellbore storage is not the dominating factor. Okay, so this is how we get. So you can see here the line. Okay, if straight line should go through the origin of the coordinate axis, several regions may a certain. So that now if it is not going through the origin, we may have a lot of problems with that. You may have a certain pressure error or maybe a time error. If such errors are plausible, the value of the offset at the origin can be used to correct the data. Okay, the correction should however be made with caution since other causes may explain the offsets. Too much time elapsed between the measurement, the Wellbore storage effect, and period is ending with the second measurement is made. Variable Wellbore storage due to gas, because gas is compressible is not the linear values. Okay, fluid segregation in the Wellbore. So generally, if your data is very correct,